Hello everyone, welcome to my channel. My name is Ashay and today we are going to talk about the two-stroke engine. So in the previous lectures we have already seen what is a four-stroke engine, the basic nomenclature of IC engine. We have seen SI engine, which is a spark ignition engine, compression ignition engine, which is a CI engine, and their detailed comparison. So in this lecture we are going to talk about what is a two-stroke engine and their thermodynamic processes. So without further ado, let's get into it. As you already aware that the internal combustion engine has mainly four processes. So first is suction, second one is compression, third one is combustion, and last one is the exhaust. This all thermodynamic processes happens within the two revolution of the crankshaft. In the first revolution, air and fuel mixture is sucked into the combustion chamber. In the second half revolution, the air and fuel mixture gets compressed and the pressure and temperature of the fluid is getting increased. In the third process, which is a power stroke, in power stroke there is a power generation because the combustion of the fuel, and the last stroke is the exhaust stroke, in which we are emitting the residual gases from the combustion chamber to the outside of the engine. These four processes needs two complete revolution of the crankshaft. But if two unproductive processes, which are suction and exhaust, are managed such that the whole cycle gets complete within the one revolution, then it's a two-stroke engine. In two-stroke engine, all the four thermodynamic processes takes place within the one revolution of the crankshaft. So for every crank rotation, we're getting the power output. So theoretically, we can get the double power output for the same speed of the engine as compared to the SI engine. So on base of this theory, in 1878, Douglas Clark invented the first two-stroke engine. So the main difference between a two-stroke and a four-stroke engine is that the two processes, the first one is the admission of the air and fuel inside the cylinder, and the next process is to emit the residual gases outside the combustion chamber. In four-stroke engine, these two processes are performed by the movement of the piston during the suction and exhaust stroke. But in two-stroke engine, the suction process is accomplished by the compression of air and fuel mixture into the crankcase, and this compressed air and fuel mixture is used to move out the residual gases from the combustion chamber outside the cylinder. So therefore no separate piston strokes are required to perform these two operations. So only two strokes are required. In the first stroke, the air and fuel mixture is getting compressed, and in the second stroke, because of the combustion process, we are getting the power output. During the first process, whenever the piston moves upwards, there is a reduced pressure in the crankcase, because of which through the inlet valve, the air and fuel mixture is admitted inside the crankcase. During the induction of the air and fuel mixture into the crankcase, the piston moves upwards and the compression of the previous cycle takes place. After the compression, during the combustion process, piston moves downwards, which compresses the air and fuel mixture inside the crankcase and admits the air and fuel inside the combustion chamber. This compressed air and fuel mixture helps to emit the residual gases from the previous cycle outside the combustion chamber. So this process is called as a scavenging. So what is a scavenging and the different types we will cover in the separate video. During the next half revolution of the crank, the air and fuel gets compressed, which increases its pressure and temperature. And at the end of the compression stroke, during the ignition of the spark, combustion process takes place. Because of this combustion process, tremendous amount of heat energy is produced, because of which the high amount of pressure is exerted on the wall of the piston, which creates the power output. During the power output, piston moves from the top dead center to the bottom dead center, which compresses the air and fuel mixture which is already present in the crankcase and admits it for the next cycle into the combustion chamber. And the residual gases are again emitted outside the combustion chamber by the scavenging process. So all the four processes, which are suction, compression, power and exhaust, all four processes are covered during the one revolution of the crankshaft. There is a deflector which is present on the top of the piston, which helps the fresh air and fuel mixture flow to the top of the cylinder, which prevents the flow of air and fuel outside the exhaust port. So these are some basic 4 processes which are involved in the two-stroke engine. So this is all about what is a two-stroke engine and its working principle. In the next lecture, we will see the detailed comparison of a 2-stroke and a 4-stroke engine. I hope you like my video, so please subscribe to my channel and also ring the notification bell to get the latest updates. Thanks for watching.